Hello students, welcome to engineering assignments. In engineering assignments, today in machine learning, we are going to learn a topic called as different types of learning. First one is supervised learning. Supervised learning is being classified into two types, that is classification and regression. Next we have unsupervised learning. Next semi-supervised learning and reinforcement learning. Here we will uncover each one of them and we will study in detail. So let us start with the first one, supervised learning. Supervised learning is a task of learning a function that maps input to output based on example input and output pair. For example, a data set is given with certain variables, say size, color, shape, fruit name. And here size, color, shape are the input variables and fruit name is the output variable. Whenever we are talking in machine learning concept, you must say it as label or class. So this fruit name can be called as a label. With this all, we implement a supervised learning model. And this supervised learning model has been learned with the help of these tables. Now, this model is capable of predicting which fruit is it. The supervised learning model is given a new set of data, like if shape of object is long curving cylinder having color green yellow, then it has to predict which fruit it is. What the supervised learning model will do? It's already been trained using this table. So it knows that if it is green yellow and long curving cylinder, then it is banana. So the output will be, or the final label will be given as banana. So what has happened here? The machine is trained using well labeled data. Now when a machine is provided with new set of example data, this is new set of example data, that is if the object is long curving cylindrical having color green yellow, the supervised learning algorithm analyzes this training data set of training examples that is there in the table and produces an correct outcome from this label data. What is the correct outcome of this label data? It is a banana. So in simple words, we can say that supervised learning is a method in which we teach the machine using label data. Here we always give a label data. That is the main point you should remember about supervised learning. And here an external supervisor will be there and feedback can be given to the machine. Some popular algorithms of supervised learning are linear regression, logistic regression, support vector machine, k-nearest neighbor algorithm, random forest. These all algorithms will be dealt in different videos. Supervised learning can be both classification and regression problem. So first we'll be dealing with what is classification. A classification is when the output variable is a category, such as you want to categorize into red or blue, or disease or no disease, COVID positive or COVID negative. When the COVID was affected, at that time we were doing the COVID test and it was given in the laboratory for testing. At that time the report will come it as COVID positive or COVID negative. So the people were categorized for COVID positive and COVID negative. Now this classification problem requires that the example to be classified into two or more classes. When it is being classified into two classes, it can be called as two class or binary classification problem. And if more than two classes is necessary, it is called as multi-class classification problem. For example, you have given with some fruits and you have to categorize into apple, orange or pears. So at that time, it is called as multi-class classification problem or multi-label classification problem. The classification can have a real valued or discrete input variable. So input variable can be real valued or a discrete input variable. Now let us study in detail what is about the classification. Suppose you are given with this training data, it's called as training data, and the score 1 and score 2 is given, as well as the result is also given. So we can say that our classifier is being trained using these data. And suppose a question is asked, say score 1 is equal to 25 and score 2 is equal to 36. What value should be assigned to the result corresponding to this new data? To answer this question using the given data alone, we need to find some rule or a formula or a method that can be used to assign a class label to the result. The problem of finding this rule or formula or the method is called as classification problem. And a discriminant of a classification problem is a rule or function that is used to assign label to the new observation. So let us see how it is done. So this is a rule which is written according to this training data which is available. It says that if score 1 plus score 2 is greater than equal to 60, then pass, else fail. You can write one more rule based on this training data. That is, if score 1 is greater than equal to 20 and score 2 is greater than equal to 40, then pass, else fail. Okay, so this is one rule which is being written from this training data. Now let us check out how classification works. Classification works in two simple steps. First is construct the model. Second one, use the model. Suppose you are given with the training data. So in the training data, the CS marks is given as 5, 6, 2, 7, 9. And the result is being displayed here, that is the label. If it is 5, it is fail, 6, it is pass, 2, it is fail, 7, it is pass, 9, it is pass. This training data is then assigned to the classification algorithm. The classification algorithm analyzes it and builds a classifier model. So the first phase is over. And this classifier model is being constructed using some rules or conditions or a decision tree, etc. Here, this classifier is constructed using a query or a rule. And this rule states that if CS marks is less than or equal to 5, then the result is equal to fail. Now, next phase is use the model. So, let us use the model. Suppose an X is given. So, here what it will happen is that it will go to this query and the CS value is given as 8. So, you have to check what is the result. So, 8 is given here. 8 is of course is greater than or equal to 5. Then the result will be the alternative one because it doesn't satisfy this property. So, its alternative value will be coming, that is pass. So, this is how the model is being used, and this is how the classification works. Now, let us discuss some real life examples of classification. First one is optical character recognition, which is a problem for recognizing character codes from their images. Next, face recognition. The input is actually image which is given here. The classes are the people to be recognized, and the learning program should learn to associate the face to its identity. Next, speech recognition. The input is acoustic and the classes are the words that can be uttered. Next, it is used in the medical diagnosis. The input are relevant information we need about a patient, and the classes are actually the illness. Next, knowledge extraction. The rule is simple model that explains the data. And looking at this model, we have to explain about the process underlying that data. Next is its use for compression. That is, classification rules can be used for compression by fitting a rule to the data, and we get an explanation that it is simpler than the data, requiring very less memory to store and very less computation to process. Now there are few examples of machine learning algorithms. First one is logistic regression, naive-bayes algorithm, KNN algorithm, decision tree algorithm, support vector machine algorithm, random forest. Now the next type is regression. In the classification, we were dealing with the discrete values or categorization was done. But in regression, the output, or we can say that the label is a numeric variable. See in this table, the age, distance, weight, prices, these are the features of a car. You can see here that the output is actually the price. The value of the output variable will be a number. See, it's a number, no? So the value of the output variable may be a number such as an integer or a floating point value. A regression problem is when the output is a real value. See here, it's a real value such as dollars or weight, etc. And these are often quantities such as amounts and sizes. The input may be discrete or real valued. For example, suppose we are required to estimate the price of the car aged 25 with distance travel 53240 kilometers and weight 1200 pounds. This is an example of regression problem because we have to predict the value in a numeric variable called as price. Let's X denotes the set of input variable and Y is the output variable. Then the model is mathematically, it is written as Y is equal to f of x comma theta, and this f x comma theta is regression function, and machine learning algorithm will optimize this parameter in such a way that the approximation error is minimized and the estimate of the values of the dependent variable y are as close as possible to the correct value given in the training set. For example, if input variables are age, distance, weight and the output variable is price, then the model may be written as y is equal to f x comma theta. So price is equal to a0 plus a1 into age plus a2 into distance plus a3 into weight, where x is age, distance, weight, and these are the set of input variables, and theta is a0, a1, a2, a3, and these denote the set of parameters of a model. Finally, let us differentiate between the classification and regression. Classification predicts discrete values, while in regression it is predicting continuous values. Here in classification, the data is classified into two or more classes. Two class prediction, it is called as binary classification. More than two, it's called as multi-class classification. In regression, it requires a prediction of the quantity. And the regression problem with multiple input variables, it's called multivariate regression. The main example of classification is to classify spam mail or not. Identify the fruit based on color, shape, etc. And these are the examples of classification. And what about the regression? Suppose we want to predict the price of a house or number of bedrooms in a house, predicting amount of rainfall obtained in this year. These all will give an output value in numeric way. So these all are the examples of regression. So students, I hope supervised learning is clear for you. The video is becoming very long. So the other types of the machine learning algorithm will be discussed in the next video. Thank you students. Thank you for watching my video.